and welcome to the Absolute Recap Biology Edition, where we aim to maximize your understanding and minimize your need for memorization. Each episode will recap content, skills, and test-taking tips to help you succeed in May. I'm your host, Melanie Kingett, and your recap starts now. Hi, and welcome to the Absolute Recap Biology Edition. Today's episode will recap glucose and its role in cellular respiration. Let's zoom out. We're in Unit 3, Cellular Energetics. Topic 3.6. Our big idea is energetics. Did you know that if you combine a small, simple gummy bear with heated potassium chlorate, you get, well, quite a scene. The gummy bear immediately and violently reacts, shaking around in your test tube, emitting a large amount of light and steam. Spontaneous combustion. Let's zoom in. Combustion reactions involve elemental oxygen reacting with a hydrocarbon and usually releases large amounts of energy in the form of heat and light. When reactants combust, or react with oxygen, the products formed are water and carbon dioxide. Combustion reactions are one subclass of oxidation-reduction reactions, or redox reactions for short. Redox reactions involve the transfer of one or more electrons. The substance that loses electrons is oxidized, whereas the substance that gains electrons is reduced. This can be remembered with a simple mnemonic, oil rig. Oxidation is losing, reduction is gaining, because the substance that accepts the electrons is reduced. What?
Explain to me what's going on.
That doesn't make sense. It might not at first glance, but it does when we use oxidation numbers.
Yes, that's what I thought.
Oxidation numbers can be assigned to each atom in the reactants and products. By looking at the change in oxidation number, we can determine if a substance has been oxidized or reduced. Oxidation numbers are a form of bookkeeping and help to determine the electron distribution of the compound. Check out episode 22 of the Absolute Recap Chemistry Edition for more details. Back to the gummy bear's sacrifice. Potassium chlorate, KClO3, is a salt which melts when heated to 365 degrees Celsius, decomposing into potassium chloride, KCl, and oxygen, O2. This decomposition creates an oxygen-rich environment in the test tube. Gummy bears are composed of sucrose, C12H22O11, which spontaneously combust in the oxygen-rich test tube, releasing carbon dioxide, water, seen as steam, and a lot of energy, seen as light and measured as heat. The light even has a lilac hue from the potassium ion. Crunch a few numbers, and you can see that over 5,000 kilojoules of energy per mole are released during the gummy bear's sacrifice.
If you were to find yourself faced with the opportunity to hunt for buried treasure, and you had the option of either A, going on that treasure hunt with an experienced adventurer and access to the treasure map, or 2, winging it and just figure it out as you go. Now, winging it is admittedly very exciting, but the phrase, "I'll figure it out as I go," is usually the last thing I say before getting very lost or spending hours digging through the trash for the furniture assembly instructions I said I didn't need. An experienced adventurer and access to the treasure map is probably the smartest option. Now swap out the word treasure map with study guide, adventurer with teacher, and buried treasure with educational aspirations, and I don't know where I was going with that. But what I do know is that we have study guides, virtual classrooms, and tutoring sessions available now at www.TheApsoluteRecap.com. Now back to the recap.
2 questions come to mind. First, why aren't gummy bears combusting on your countertop then?
Why not, indeed?
And second, why aren't our cells bursting into flames during cellular respiration?
Well, why not?
The temperature of the potassium chlorate solution provided sufficient activation energy for the gummy bear reaction. This environment doesn't exist on your counter, even though there is plenty of oxygen. The title of this episode is Glucose Combusting. During cellular respiration, glucose in your cells reacts with oxygen to release carbon dioxide, water, and energy. Just not all at once, but rather in a series of redox reactions. so no bursting into flames. In eukaryotes, cellular respiration involves a series of coordinated enzyme-catalyzed reactions that transfer energy from biological macromolecules. Cellular respiration is a catabolic reaction, exergonic with a negative delta G, or Gibbs free energy. It releases 686 kilocalorie per mole, 40% of which is transferred to ATP, adenosine triphosphate, for cellular work. The energy which is not transferred to ATP is often lost as heat. Certain organisms, like endothermic birds and mammals, have insulating structures to retain metabolic heat and aid in maintaining homeostasis. Glucose is gradually oxidized through several steps during the process of glycolysis in the cytosol of cells and during pyruvate oxidation and the Krebs cycle in the inner mitochondrial matrix. When glucose is broken down, some energy is directly transferred to ATP through an intermediate known as substrate-level phosphorylation. Greater amounts of ATP are formed indirectly by chemiosmosis following the electron transport chain. This indirect process of ATP formation is known as oxidative phosphorylation. Quick aside, this is known as oxidative phosphorylation in cellular respiration and photophosphorylation in photosynthesis. Same process. Cellular respiration is a gradual transfer of energy through the use of electron carriers, NAD+ and FADH. These coenzymes are reduced into NADH and FADH2. Electrons removed from glucose are eventually transferred to oxygen, which joins hydrogen to form water. Oxygen is called the final electron acceptor and exists at a lower energy state than glucose. Hence, cellular respiration is exergonic. Time for unit connections. Cellular respiration doesn't stretch too far beyond Unit 3. However, there are energy connections to Unit 8 with ecosystems. You'll also find glucose in Unit 1 with biological molecules. All right, what about the exam? There are several exclusions associated with cellular respiration. Specific enzymes, except ATP synthase, intermediate molecules, proteins in the ETC, or specific steps of glycolysis and the Krebs cycle are beyond the scope of the AP exam. Be prepared to answer questions that compare and correlate cellular respiration to photosynthesis. Additionally, a disrupted system is a favorite question format, perhaps asking for a prediction on energy output or rate of metabolism for an organism. To recap, cellular respiration is an exothermic combustion reaction. In the presence of oxygen, glucose combusts to yield carbon dioxide, water, and large amounts of energy. Some of this energy is transferred to ATP for cellular work. Coming up next on the Absolute Recap Biology Edition, activation energy. Today's question of the day is about redox reactions. Glucose is oxidized, so what molecule is reduced in cellular respiration? For the answer to the question of the day, please follow us on Instagram at TheApsoluteRecap. That's the APsolute recap. Check out our website, TheApsoluteRecap.com, for episode schedules, study guides, virtual tutoring, and to sign up for our virtual classroom. The Absolute Recap is produced by Brad Kingett with music by Zach Caruso. Today's episode was written by me, Melanie Kingett. Thanks for subscribing, and don't forget to rate and review wherever you get podcasts. Time's up. Pencils down. Thank you for listening to the Absolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, Absolute Recap LLC, all rights reserved.